Let's talk about first the innovation. When I say innovation, it means in the world of the internet, just like what Sir C. But sa akong end, it's for web technology, no? Innovation of the web technology. So we have Web 0. I don't know if there is a term called Web 0, but this is one of the things that I've learned during our PBA in Hong Kong. We have this Web 0. No? So during this time, people were just using telephone, telegraph, and users can transmit their data peer-to-peer, and the cryptography is not yet, not that really used, because during this time, it was only used by the militaries. No? So that's Web 0. Web 1, this is the time the introduction of the always-on servers, still mostly peer-to-peer, and cryptography more often, but still not that really present during that time. I think Sir C already gave you an examples. So this is the time where the users can only view the web page. So, and during this time as well, mao ni siya ang commercials, advertisement. Users will just have to view only without interacting the web application or website. And then for Web 2, this is the time for introduction of digital services with rich state administered by service providers. So just like what Sir C he explained earlier, in Web 2 we have this so-called central authority. They are the ones who control, have all the rights to control your data. And this is the time as well that we have to trust the service provider sa atong data na atong isan sa ilahan. So we have to trust them about our data security and data privacy. And cryptographic guarantees are about interactions with the service provider, not peers. So mostly, cryptography is only implemented sa service provider, not on the user's end. So this is the example. We have the typical one, Web 2. We have user login or user registration. You have to provide all your information, and then there are some sort kind of API to process all of your data and then store in their servers. No, the typical one, the typical na Web 2 karon, no? Just like Facebook. No? So when we post something, our data nga atong gi-post will also be saved, will be saved or stored in their Facebook servers. These are the examples of the digital services. So like what I said, Facebook, Twitter, Instagram, etc., journalism, banks as well, as what Sir C explained. We have to trust the bank that sa atong money nga atong gi-put sa bank. You have to trust that they dili nila i-steal or gamiton for other things. So trust, this is just an example. No? 2 users on Twitter. So trust that we are seeing information from the same database, and trust that if we if a tweet is from this user, then that user wrote the tweet. Trust that others see our messages as from us. Trust that the messages we see are the messages the users wrote, and trust that we're interacting with the application as equals. So these are the typical Web 2. We have to trust the service provider. In Web 2 as well, enables the service provider in God mode, to be a God mode. So, for example, like Facebook, who is the God of Facebook? Diba? Mark Zuckerberg. So, Mark Zuckerberg can also perform such abuses, no? For example, like this one, censoring users' interaction, restricting users' interaction, failing to produce requested data, mutating or editing your data without knowing, no? And they can even shut you down because they are in control. So that's how God mode na enabled. Now in Web 3, This is the time the provision of digital service without the need to trust a service provider. No? So providers do not need also to be trusted. They are economically incentivized to behave honestly, and it also allows users to interact with a common system without trusting any intermediaries. In Web3, as you can see in the picture below, unlike Web2, this one, you have to put all of your information or sort of like KYC, no? KYC. But in Web3, you just have to create your wallet without putting names, email, etc. And then once you have that wallet, then you can already interact sa blockchain. Or for example, like this one, Polkadot, Zone, and other parachains. So let's talk about blockchain. In blockchain, the world of blockchain, you need to have these 6 desired properties. Kung usa saan ay wala, then that is not blockchain. No. So number 1, it has to be permissionless. Anyone can interact sa system without mo restrict sa imong haba. And then authenticity. You can guarantee that the data that you put in blockchain is the actual data. Because once the data is being recorded or stored in a blockchain, it cannot be altered or changed, edit, or delete. So we can guarantee authenticity. And behavior as well, like smart contracts. Smart contracts are very transparent. Makita mo dyan mo ang code. You can see the code publicly. No? Whatever is being written in that code, most of it ang ma-execute. Okay. And then of course, privacy. In blockchain, di po na siya matawag o blockchain without cryptography. No? So, cryptography is the one na nakapakuha ng privacy, sa data privacy sa usa ka user. And of course, finality, just like I said, once the data is already in blockchain, it is there forever. No? It is final and it is stored in that blockchain forever. You cannot edit it, you cannot delete. It is there forever. And finally, unstoppability. No, you cannot stop the blockchain technology because, as what Sir C explained, it is decentralized. No, so as long as there is one server running sa usa ka blockchain, buhi gyapon yung blockchain. No, as long as na mag-run nga server, and anyone can be a server. No, so these are the 6 desired properties sa blockchain. Blockchain is just a shared history. So once you have a transaction that you have executed and stored in a blockchain, it will become history. No? I will explain later on anong ingana siya, shared history. So like this one. No? So blockchain is also just a state machines. Are you guys all computer science? Or is it computer science dali? So kani siya, subject na siya sa computer science, just a state machine. You have the genesis state or pinaka first na state. So you have this first state and execute some transition, and then that state will become that first state will become as history, and then a new state will be created. No? I have another example, like this one. No? This is just a simple switch, state machines. So on and off. So on is the first state, and then the transition is toggle, then the next state will be off. Then toggle again, on, toggle off. So, and it will become history. State 1, So Alice and Bob, Alice has $5 and Bob has $10 in their account. And then Alice spent her $5 and it will become now this the state 2. So Bob has the $5 already and Bob has $10 already. Shared history of a state machine. So if we agree on the starting state or the history of transitions, then we must agree on the current state. So if we agree on this state, then we must agree on the current state. So what is blockchain really all about? So a blockchain can be thought of in 3 parts. So number 1, the state machine. Number 2 is the shared history. And of course, a general agreement, which is the consensus. So which history is the real one and what part of history is final. Let's talk about blockchain structure. So again, this is a computer science subject. Blockchain is just a hash linked list, but dagan pa siya klase. There are many types of structure, no? But this is the very common one. So we have this first block, and then that block is gonna be hashed, and then that hash will be the parent hash of the second block. So for example, like this one, this is the hash potato. So this is hash, and then this hash will become the parent of the next block. And then this block is gonna be hashed again, and then will become the parent of the next block, and then so on and so forth. So the first, we call it Genesis block, ang pinaka-first na block ma-produce sa blockchain. So Genesis block. Blockchain meet state machine. Explain ako later on. Actually, blocks and states are 2 separate things, no? At 2 separate. Kung sa computer pa, 2 separate files. Yan na. So, like this one. You have the blocks here, and you have the state. And this state, connected din na siya sa mga blocks. I'll explain it sa second slide ata. So like this one. So you have this first block, then with bunch of transition or transactions na imong i-execute. And then once the transition is being applied for that block, it will become a new state, and that state is gonna be hashed, and then i-save siya sa state root sa usa ka block. So kani siya nga state, it will be this one, kani siya nga state, this one. So 2 separate things. This is just a sa realistic blockchain structure, no? Sa usa ka block, no? We have a header and body. Header is the summary of minimal important information about this block, and body is a batch list of state transitions or transactions. No. I think dapat to example din. Substrate is a framework that is used to build blockchains. No? I'll explain later on magparaan naman tag substrate after this talk. But this is code inside sa substrate na framework. So, familiar ba mo Rust? Tanan? Rust? Rust man ilang gamit nga as their main programming language. So, they have 2 properties in here. Header, and then extrinsics. These are the body, but they call it extrinsics. Actually, extrinsics are just the transaction, no, inside sa usa ka block. If familiar mo Rust, na vector is an array, no, sa Rust. No? So one header and multiple extrinsics. So this is a substrate in full picture. So we have header, the parent hash, and then the state root, and then extrinsic root, which means ang pinakauna nga extrinsic na lisod sa usa ka block, and then and so on and so forth. and body as well, the transition. Then all of them are just, they are connected sa mga states. So, yeah, like I said, string syncs are just a transaction, no? If you could see in the picture, no? Si Bob, nag-check siya sa iyang, nag-transfer siya kay Dave, o, I don't know, pila na siyang amount. So, string syncs is just a transaction. Later, I will show you na kung saan siya string syncs, no? Magkita nato ni as we proceed sa atong workshop. Alright? So, substrate framework. What is substrate? No? Substrate is a Rust framework for building blockchains. So, like I said, if you want to create your own blockchain, then use substrate. Then why? Why substrate? Because future is a multi-chain, no? And building a blockchain from scratch is very hard. Try na ba mo create a blockchain from scratch? So, upgrading it, even harder. And Substrate is also a framework. So, mas dali i-build a blockchain using Substrate. Rust is the one that, mo na siya ang main programming language sa tanan source code sa Polkadot. No? Why? Nga mang Rust? So, first line of defense, it prevents human error when possible, and is a safe language, no memory safety issues. Even Microsoft and Google, no, they have already switched most of their applications ngaylang develop. They have already switched to Rust as their programming language. No? As first stated here, Microsoft and Google have each stated that software memory safety issues are behind around 70% of their vulnerabilities. So 70% is quite big. No? Dako ang kung sa kwarta pa, dako kasi lang nadaginot. No? So, yeah. These are the parts. Substrate in full picture. No? The good thing about Substrate is that, number one is that you can easily build your own blockchain. Number two is your blockchain is upgradable using the Substrate. Because WASM raman siya. Familiar mo WASM or WebAssembly? No? So, what you have to do, if you want to upgrade your blockchain, you just have to compile your code and then generate WASM file and then upload to your existing running blockchain. So, that's the good thing about Substrate. And then later on, I'm going to discuss the node, the runtime, as we proceed sa ato ang workshop. So if you want to learn more about Substrate, you can visit this website, no? Substrate.io, www.substrate.io. Complete ang ilahang documentation. So, let's build a blockchain. First and foremost, since Substrate is based on Rust, programming language, so of course we have to install Rust. So, you just have to go to their website, Rust, maybe I could install Rust up. So, this one. So, you just have to run this on your terminal and then restart your terminal, then you already have your Rust programming language installed in your computer. Then after that, you just have to go to GitHub, no? Actually, all of their repositories are Partech. They are all open source, so you can download it anytime, no? So you just have to search it here, Substrate, Developer Hub, and then Zoom, no? Correct. And then they have this Substrate node template. This one. Well, I have already cloned this in my laptop. So I'm just gonna show you the code already. This is a Substrate framework na repo, akong gi-clone. And then there are three important directories na atong that nga atong kailangan hibaw-an. Number one is the node. Node is, this is mo ni siya ang jig sa runtime or sa imong RPC. Mao po ni siya ang mo-govern sa nodes kung imo siyang ipadagan sa imong local computer. Like, unsa mga pasabot na kung humingon tagi-govern. Like ang pag-save sa data. When you transfer balances, i-save yung balances dito sa blockchain, then si node ang na responsibility. Then we have this runtime or logics here. Actually, runtime are just the implementation of all the palettes that you have created under this directory, this one palettes. No. Actually, all of your logics na gina diri sa palette. Wala sa runtime. Runtime is just sort of like a registration of all your palettes that you have created, and then ang runtime pod ang execute padulong dito sa node. Yan na siya. So I don't have to explain everything. Given ang time, no? So what I will do is I will just run a command. Well, I've already built this substrate node, no? Template. But when you build this one, you just have to run this command, cargo build release. But it's already finished now since pag mag-build ka, take check time. Labi na if your substrate imong application is quite big, no? So mo take check time ang pag-build. But I have already built this one. We just have to run it, no? Now to run it, you just have to type this command, target release, no template. Zoom sa pag-zoom ni. Kung ba ang zoom So my RPC or my substrate node is currently running, and then kung running na siya, all you have to do is just go to their website, this one, the polka.js.org apps explorer. So as you can see, nag-create na siya mga blocks, this one. Meron siya mga blocks, nag-create niya. And then, each block, we can see the block details, no? So, meron siya mga extrinsics. So if mag-perform ka transactions, for example, mag-transfer ka, your transactions will be recorded sa kaning extrinsics. And then, of course, this is the header. We have the hash, the parent hash. This is the current hash, the parent hash. If imo ni siya i-click, navigate siya sa form, sa previous niya nga block. So, and then, sa substrate pod, built-in na ang mga transactions na pwede na ito ma-execute. Like for example, mag-send ka og funds, no? For example, mag-send ko funds kang Alice to my wallet, then I could do that here sa substrate. It's already built in sa ako ang substrate nga akong padagan sa template na gi-provide ni Polkadot. So, blockchain and substrate. Thank you.
Wait 5 minutes.